Good morning, everyone, and welcome to our webinar, Understanding Service Mesh on Azure with HashiCorp Consul. Our speakers today are going to be Nicole Hubbard, Developer Advocate at HashiCorp, and Zachary Deptala, a Cloud Developer Advocate at Microsoft. This webinar is being recorded, and we will be posting a copy of this to our website in about 1 to 2 days. During the webinar, feel free to enter your questions into the chat. We'll be answering them throughout the presentation, then also answering questions live at the end of the presentation. This one's a little bit different. We are going to be showing a recorded version of the webinar. So we'll be answering things live in our chat function. And then again, we'll be coming back at the end to answer your questions. And with that, we're going to go ahead and get started. Thanks.
Hi, everyone. I'm Nicole Hubbard, a developer advocate for HashiCorp.
And my name is Zachary Deptala. I'm a cloud advocate at Microsoft, focused on modern operations and DevOps. We're also both active on Twitter, so feel free to reach out to us after this presentation using our Twitter handles if you'd like. In this session today, we'll be covering what microservices are at a high level, how the networking for microservices differs from traditional infrastructure, what AKS is, what Consul is, and how it works with AKS, and we'll finish up with a demo and some time for Q&A. So let's start off by answering these questions. What are microservices, and how is the networking different from traditional environments? To get started, I'd like to talk a little bit about monoliths, and that's kind of what I've referred to as more traditional infrastructure or environment so far. In this diagram, we're looking at a monolithic application. And as you can see, this application has several pieces that need to communicate with each other, and they're denoted by boxes labeled A, B, C, and D within this application in this diagram. So for this communication to happen, it's relatively simple. In a monolith, the different parts of the application have no issue really communicating with each other. A knows where B is and can make that communication happen. And this is because all communication happens in memory between the different pieces of this application, being they all exist within the same application. Scaling an application like this horizontally would mean adding more instances of the entire application, because behind something like a load balancer or proxy, and this is due to the close coupling of these different parts of the application. They're all in the same application. So as you scale out, every portion of this app is scaled out as well. And now let's take a look at the same application using microservices. As you can see, all of the pieces of the app are still here, but they're now decoupled. So when we talk about microservices, what we're really talking about is a separation of concerns within the application. We're splitting the application up into smaller pieces using things like serverless virtualization, containers, and highly automated and dynamic environments. And the key is that they're decoupled and can communicate with each other through protocols like TCP, HTTP, or even REST API endpoints. So when you decouple pieces of an application into microservices, you're able to more finely tune your horizontal scalability. You're able to scale each portion of the application independently based on the load of each microservice versus scaling them all at the same time. But decoupling applications into microservices can add challenges that we need to overcome. It's definitely not as simple as breaking your application up into several logical pieces and putting them on separate services or servers and calling it a day. When we decouple the application, one of the first hurdles we're going to run into is communication. And we've got the separation of concerns piece taken care of, but in a truly dynamic and automated and self-healing environment, how will these microservices know how to talk to each other? And one way would be to hard code the IP address of each service, so each service will know where the other one is based on that IP address. But what happens when you begin to horizontally scale each service or each microservice as load increases for that microservice? You begin dealing with multiple IPs, and how will our microservices know how to communicate with each other after an auto-scaling event or during a failure of some part of one of these services? Or what about the event of a complete outage of one of these microservices? A more traditional approach at handling this is to simply add a load balancer between these services. And the load balancer can be aware of the services behind it. It can health check each service or instance behind it and make sure that it's healthy before traffic is sent. And it's great, but it's not always quickly scalable depending on your environment. And in this example, we need a load balancer or at least a pool in front of each of these microservices. If we wanted to achieve HA or high availability, we'd actually need to add at least a pair of load balancers or pools for each of these microservices for failover. And depending on what provider you're using, that's not very cost effective. There are now much more cloud native and microservice friendly solutions, and really that's what we're here covering today. So most microservices are built utilizing containerized environments, and using something like containers, that allows you to easily isolate parts of your application within containers. It also allows for quick, reliable, and repeatable deployment of these containers into your environment. But when you start looking at using containers, you also start dealing with new concerns that were not previously there. And container orchestration handles things like scheduling, affinity or anti-affinity, which is how closely or loosely containers and services are deployed in pods, health monitoring, automatic failover scaling, networking, service discovery, and coordinated application upgrades. And this is what container orchestration really excels at. And also, this is where Kubernetes comes in. Kubernetes is one of the most popular container orchestration technologies that exists today. It's super portable. It can be used on public cloud, private cloud, hybrid environments, even multi-cloud environments. It's very extensible, and it has really cool features like auto-replication, auto-scaling, and that can assist in self-healing. And you can also deploy your applications very quickly, very reliably, and it will also help you limit your hardware usage to only the required resources based on what you've scheduled. So Kubernetes in itself is super awesome for container orchestration, but what if you only want to focus on your application and you don't want to worry about the operations side of things, you don't want to worry about the infrastructure that's running it? Well, that's where something like AKS comes in. And AKS stands for Azure Kubernetes Service. So simply put, it's a fully managed Kubernetes experience running on top of Microsoft Azure. And using a service like AKS, that allows you to focus on building your application in containers, so you don't have to mess with standing up, patching, or maintaining the servers that are required to run Kubernetes. It allows you to work how you want with open source APIs, and you can scale and run your applications confidently, being it's running on Microsoft Azure. So getting started with AKS is really quick. It's just a single command using the Azure CLI tool. You can have a fully featured Kubernetes cluster up and running. And the steps shown here on this slide in order are basically creating a Kubernetes cluster. That's the AZ-AKS create. AZ-AKS install CLI will actually download and install kubectl for you. AZ-AKS get credentials is actually pulling the credentials for that cluster and setting them as your current context or as my current context. And kubectl get nodes is just me making sure I'm able to connect and that I'm hitting the proper context that I'd like to be hitting. And also, we want to make sure that managing a Kubernetes cluster is simple after it's up and running on AKS. It's great that you can spin it up and connect to it, but what about managing it moving forward? So using either the Azure portal or the Azure CLI tool, you can easily upgrade a running cluster in place to a specific version of Kubernetes. And this AZ-AKS upgrade command, it looks super simple, but what's actually happening on the back end is quite a bit of what I guess is commonly known as heavy lifting. So when you run that upgrade command, Azure is actually upgrading the control plane of your cluster, and then it's safely performing a rolling upgrade of Kubernetes on each node. And it ensures first that each node is drained and made unschedulable before each upgrade. So this is very, very powerful hands-off feature that does a lot of heavy lifting for you. And you can also easily scale the size of your running cluster using the AZ-AKS scale command.
And so as you start to move into Kubernetes and more dynamic infrastructure, you start to face some new challenges. And amongst those are service discovery, service segmentation, and service configuration. So what do we mean by that? So let's start to dig into those. So service discovery. So what this is how does service A figure out how to talk to service B? So in this case, service B comes online and it's going to register its instances as they start in the registry. And then when service A wants to talk to service B, it will ask the registry, hey, how do I talk to service B? And so the registry will return one of the IP addresses. And then service A is able to connect directly with service B over that IP address. So this entire flow, the registering, discovering, and connecting, can happen a couple different ways. Inside of Consul, we actually register our applications with Consul, and Consul acts as a service registry. And then services can ask Consul, how do I communicate with these services? And it will return the IP address. Inside of Kubernetes, you also have service discovery happening through the built-in DNS management that can happen for services that you create inside of your Kubernetes cluster. Now, service segmentation. This involves how do we segment what services can talk to one another. So when we look at our monolith process to begin with, where we started, we had an external load balancer that limited the traffic coming into our monolith application. And then from there, we usually also would have another firewall that limited traffic between our application layer servers and our database. And this was just to limit what could happen in terms of communication. But we didn't need any limits between all the different components within the monolith because they were the same application. But as we start to break this out into microservices, now we have service A that needs to talk to B and C and so forth between all the services. But there's cases where some services don't need to be able to communicate with other services. Or even more so, as you continue to grow, you may have regulatory requirements that force you to be able to limit what applications can talk to your other applications. And so we have some customers who deploy over 4,000 applications, and managing all of the different rules that you would use to limit those can be challenging. And so when you start thinking about, like, I've got 5 services, that's not hard to manage. You can deploy network policies within Kubernetes for each service, and you can see what can talk to each other through those deployments of your network policy. But as that starts to grow, you start to run into problems like wanting to be able to view the entirety of your network policies. And so that's where Consul. And so next, one of the questions I get asked a lot is, what is service mesh? And so service mesh is a couple of components combined that make a service mesh. One of those components is a certificate authority. And the reason the certificate authority is important is we use that to create 509 TLS certificates, and those are used to handle authentication as well as identity. So when a service tries to talk to another service, it will pass that certificate saying, this is who I am. And since that cert was signed by the CA, we know that it's correctly identifying itself. And then we're also able to validate that the server we're talking to is the server we expect to be talking to, because it returns a certificate saying, this is who I am. And then we're also able to use these certificates to encrypt all of the traffic between services, just the same as we encrypt traffic over the public internet. And so this helps us start to create a zero trust network where everything flowing inside of our network is also secured. So then there's the actual service mesh components. And the 2 big components there are the control plane and the data plane. So in the case of Consul, Consul acts as a control plane. And we run the Consul server, which keeps track of all of the data we're setting for all of our clients and services, and where those are located, storing the service registry, all of those pieces, as well as where we set the rules as to which services can talk to one another. And then Consul pushes those changes into the data plane. And the data plane is responsible for sending traffic between different services. And in this case, we can see that we're using Envoy as our proxy. So all of the traffic will flow through these proxies in the data plane, and those proxies will rely on the control plane to tell it what traffic is allowed to flow. And then we also have our service access graph. So what that is responsible for is which services are allowed to communicate with one another. And so in the case of Consul, we use intentions to do this. And so here we see an example of creating an intention that says our web service cannot talk to any other services. So we deny all of that traffic. And then we go through and we create another rule that allows traffic between our web service and our database service. And when we're actually filtering traffic and applying these rules, we will look for the most specific rule and apply that one first. So even though we have a rule that says don't allow the web server to talk to anything, we have a rule that specifically allows the web server to talk to the database. So when the web service starts to reach out and talk to the database, it will be able to communicate with it. And one of the nice things with Consul is you're able to list all of these intentions via the command line or through our web UI. And so you can come in here and you can see every intention that you have for your entire network and be able to see which services are allowed to communicate and see it all in one central location. So one of the hard parts when it comes to integrating all of these is, how do I make this work with my application? What changes do I need to make? In general, you don't have to make any changes to your apps. What happens is when we deploy your application, we will deploy a sidecar proxy. And that proxy is what's responsible for handling all of the pieces with the service mesh. So the only real change you have to make in your application is changing the endpoint you talk to from the database directly to a local host that represents the port on the proxy that will talk to your database for you. And to do this inside of Kubernetes, it's very simple. The only thing you have to do is add this annotation here, which is console.hashicorp.com/connect-inject. And what that will do is that will tell the mutating webhook that we can run inside of our cluster to automatically add our proxy servers to our existing pods. And we can see this later when we do a demo. And so how do these sidecar proxies work? So in our standard setup, here we have two nodes running. Each node's running a console client. They're both talking to our console server, which can be inside or outside of the Kubernetes cluster. And then on the server on the left, we've got our web server running. And on the server on the right, we have our database instance running. And so when the web server wants to talk to the database, the web instance talks to its proxy server. And then the proxy says, okay, console, where is the database? And this is that service discovery component we talked about earlier. And so console will return the database IP address. And then from there, the proxy will initiate a TLS handshake to the proxy server for the database. And then what happens is the proxy server for the database will talk to console and say, hey, is the web service authorized to talk to me? I'm the database service. And in this case, the console will return, yes, the web service is allowed to talk to the database service. And so the TLS connection will be established by the proxy service. In the case that this wasn't authorized, the proxy service would have immediately dropped the connection and terminated it. And now here we can just allow the traffic to continue to flow through this proxy as it would if the proxy wasn't even there, except all of that traffic is now encrypted, even if your underlying traffic that hits the proxy server is not. So now let's jump into a demo.
All right. Thanks, Nicole. I'm going to show here. Okay. Now I'm at my terminal. We stood up an Azure Kubernetes Service cluster earlier. And what I've got here is a dashboard.yaml file that I'm going to use via kubectl. And you can see that it's setting up a pod called dashboard that's got a container running named dashboard using this image HashiCorp dashboard service open on port 9002. I'm setting an environment variable there. Then I'm also setting up a service that is named dashboard service dash load balancer, which is basically a type load balancer that's going to be used for that dashboard pod, taking requests on port 80 and sending them to port 9002. So what I can do, I can use kubectl just like normal. I'm going to apply this YAML file. And you can see that it's created my pod. So if I do kubectl get pods, we'll see that it is running. And now if I check I can check the services as well. You can see that I have this load balancer running here. I'm going to grab the external IP and I'll hit it here. And you can see that it's working, but the counting service is unreachable, but we are hitting that live Kubernetes cluster right now and that service that was created.
All right, so now that we've got our dashboard deployed, let's go ahead and get our actual backend counting service to be running. So to do that, we're going to jump over here. And what we can look at is the first thing we need to do is we want these to communicate over Consul. So the first thing we're going to do is deploy Consul into our cluster using Helm. And so we would run this git clone command to check out the Consul Helm repository from Git. But as you can see, I've already checked this out. And so if we go ahead and look in here to see what's in here, we can see that looks kind of like a standard Helm chart. We've got a chart.yaml. We've got a README that explains how to use this. And then more importantly, we have a values.yaml. So if we take a look in here real quick, these provide all of the default values for our Helm chart. And so if we look, we can see all of our defaults. And by default, we're going to set our data center here to DC1. We're going to go ahead and change that. And then another piece is the actual connect component. And so we can see here connect by default is true for that. And so what we can do is go ahead and exit out of there and come back over here. And we've created inside of here, we have a Helm console values YAML, which this is our values that we're going to use to override the default values in that Helm chart. And so what we're going to do is change our data center from DC1 to AKS-webinar. And then we're also going to set the connect inject to enabled true. And what that does is that will deploy the webhook that I talked about that will actually allow us to automatically add our sidecars to our pods just by adding that annotation. So let's go ahead and deploy this with just a Helm install with our Helm values. And we'll call this deployment console. And so this will go through, and what this is going to do is this will deploy for us Helm clients as a daemon set to every node. It will deploy the Helm, no, not Helm clients, sorry, Consul clients as a daemon set within the cluster. It will deploy Consul servers. So by default, we deploy 3 of those. And then it will also deploy the mutating webhook. So if we take a look at everything we have running, not Helm. Everything we have running now in the cluster, we can see that we have 3 Consul servers, and then we have our connect injector webhook, and then we have 3 more instances of Consul that happen to just be our Consul clients. So now all of these are running. So let me jump over here to this tab, and let's go ahead and create a port forward, which will allow us to talk to one of the services we just deployed, which is actually our Consul UI. And we'll forward port 80 locally, forward port 8080 locally to port 80 for the service. So now that's running, so we can come over here to the browser and we can hit localhost 8080, and we can see here's our Consul server. By default, the only service that's actually running right now is Consul, and we can see that our data center here is set to AKS Webinar. And then like I was talking about earlier with intentions, we can see that we currently have one intention that allows the dashboard to talk to our counting service, and all services are no longer able to talk to any other services. So we block all traffic between services. So the next thing we can do is we can now deploy our counting service. So let's take a look at the YAML for that. So what we're going to do is create a service account, and this represents the service account that we'll use for inside of Consul to represent the service if we were leveraging AKS. And then we create a pod, and we name this pod counting. We set the annotation for console.hashicorp.com, connect inject true, and then we specify a single container. And the only container we're going to add is a counting container running the counting service, listening on port 9001. We don't create a service so that it's accessible within the Kubernetes cluster. The service will only be accessible through Consul Connect features. Also, we won't be able to talk to this even if we did create the service, because the counting service only listens on localhost. So it requires the proxy to be able to talk to it. So let's go ahead and apply this counting YAML file. And we can see that we now have our counting pod starting. But what's interesting here is we have 3 containers running within this. So if we dig into this and we describe the pod counting with Kubernetes, we can actually see up here that we have our containers. So we've got our counting pod with our counting service that we've defined. And then we have a new one called Consul Connect Envoy Sidecar. And so this is that sidecar that runs to make sure our services are able to communicate. And we have a Consul Connect Lifecycle Sidecar. And this one just manages Consul and ensures that that sidecar is properly running and configured. And so all of those were deployed for us automatically by just setting that annotation. And now we can see that our counting service is running. So if we come back over here to our services in the UI, we can now see we have a counting sidecar proxy and our counting service, and they are passing health checks and able to be talked to. And so if we dig into nodes, we can actually see where all of our services are running. And we can even drill into individual nodes. So this one here has 3 checks that are passing. And the reason it has more is this happens to be where some of our services are running. So we can see the counting sidecar proxy running here and passing health checks so that we know it's available. And we can see that the counting sidecar proxy, as well as counting itself, is available here. So if we jump back to our service list, so next we need to enable our dashboard to be able to talk. So since we created this as a pod to make things a little easier, we're going to go ahead and delete that pod since pods can't be updated. Then let's take a look at our new dashboard YAML. The only thing we've changed here is we've added our Consul Connect Inject annotation to true. And then we added another annotation, and this one's Connect Service Upstreams. So what this says is we want this proxy to be able to talk to the counting service on port 9001. And so this will cause the proxy to start listening on port 9001 locally for the dashboard service. And then we set here our URL for how to talk to the counting service to localhost 9001, and that will allow it to go through the proxy to the proxy for the upstream service, counting upstream service, and return that data. So let's go ahead and apply this now, or I guess create technically, since it's just a pod. Oh yeah, it already exists because we haven't changed the service and you can't recreate it since it exists. So as we can see over here, we already have our new dashboard sidecar proxy that's still starting up. One of its health checks not passing yet, but our dashboard is online and available. So if we go ahead and look at our services again, we can grab this IP and we can come over here and we can hit the IP and we can see that we are able to connect with the dashboard and that they are connected and they're able to talk. So one thing we can do is if we come over here and we look at our rules and we delete this rule that allows the dashboard to talk to counting. And so now the only rule in place is one that says they can't. We can see that the service is now unreachable again. So if we were to delete this default rule that denies all traffic, we would see these are now connected again and they're able to communicate. So we can come back over here. We can go ahead and create a new rule that blocks all traffic again, just like that, and all traffic is blocked. And we can see when this makes its next attempt, or we can just refresh, and we can see that the counting service is unreachable. Then we can go ahead and create that intention that allows the dashboard to communicate with counting and allow that. and now we're able to communicate again. And so the nice thing here is all of the traffic between the dashboard and the counting service is now fully encrypted using those certificates that we generated. With no changes to the applications don't know anything besides what port to connect to. And if you remember over here, we're connecting on HTTP. So this isn't secure on localhost. The clients don't know that it's secured, but the transit between the services, specifically between the proxies, is now secured. And the nice thing is we're able to use the same mechanism to extend traffic between Kubernetes clusters, to extend traffic out to VMs. So your service is running on VMs talking to things in Kubernetes, or the services in Kubernetes talking to things in your VMs. So in the future, we're going to do some more webinars. And one of the topics we'll be covering is how to secure the traffic between your VMs and your Kubernetes cluster. And then also on April 15th, we have a Consul Adoption Day, where we'll also walk through some of these Consul Connect features that I just showed, as well as how you can actually use Consul Connect and, because of the proxies, do network observability and build dashboards to be able to see your traffic, see errors between your applications, and get all of that reporting information without making any changes to your application besides just deploying Consul into your cluster.
Okay, we're going to be getting started with questions here in 1 second. Before we get started with that, I did want to let everybody know that we are going to be having, if you're looking for more content, as Nicole mentioned at the end of the video, we are going to be having a Consul Adoption Day on April 15th. If you follow this link, hashi.co/Consul Adoption Day, you can go ahead and get registered for this. As well as if you're interested in learning more about HashiCorp Consul services on Azure, which is the managed version of Consul, we are offering signups for a private beta still. If you go to hashicorp.com/HCS/private-beta, you'd be able to potentially sign up to participate in that. With that, I'm going to go ahead and open it up for questions. And so, Nicole, one of the questions that came up was talking about intentions, and so managing intentions at scale. And so they had a question about, like, intentions are authenticating the client certs against Consul. So are those being cached, and what are the challenges of running like Consul at a high production level because of it needing to make requests for each service and authenticating against those certs?
Yep. So this is a good question. And so what happens is the Consul server will push all of that information to the local Consul client. So that data is local. It doesn't have to go off the machine. The proxy does have to talk to the client. However, it's not for every single request that comes in. It's only when the proxies initiate the connection between one another. Once that connection is initiated, they will actually leave it open and reuse it between requests so that you don't have to re-authenticate for every single request. It's only at the beginning of the connection. So really, it's the first time that, in the case of Kubernetes, it's the first time that that sidecar proxy talks to the other sidecar proxy that it has to be authenticated, and that's it.
Excellent, thank you. Another question is asking if they can define intentions directly from the manifest.
So currently, this is not possible. We are discussing internally and looking at how we could build CRD implementations that would allow you to manage the Consul intentions as well as some other features from within Kubernetes using only Kubernetes manifest. But right now that is not possible.
Thank you. Zach, this may be a question for you, asking about how do you set up proxy database design when you're using Azure Database as a Service?
I think this is referring to the proxy that Nicole talked about, right? On the slide with that proxy. Nicole, on that proxy that you showed, was that something that Consul is setting up?
Yeah, so Consul is setting that up. We are actually actively looking at how to handle egress proxies so that we're able to handle things that, for example, when you're running using one of Azure's numerous databases as a service offerings, so that you can still connect through that through your service mesh. So there is work happening there now.
Yeah, because for any kind of proxy that's connecting to the database as a service, you'd have to use that connection or that endpoint in some manner. So yeah, we'll have to wait for that feature, I believe. Yeah, Nicole?
Correct.
Thank you both. This is a good one because it kind of spans multiple questions. I know there was a question about like in comparison to Istio. Nicole, can you talk a little bit about using Consul for VMs versus containers, or even using Consul for VMs and containers?
Yeah, so I see a couple questions in here that I'll try to hit on in one. So one of the things with Consul is once you get your cluster up and running, you're able to connect VMs, containers, anywhere you can run a Consul agent can join the service mesh. And so this actually allows you to securely connect services between VMs and other VMs, between VMs in your Kubernetes clusters, between the Kubernetes cluster and the VMs. So if you're running your own database, for instance, on a VM, and you put the agent as well as the proxy in place, you could actually securely connect with that. One of the questions is each of these services on different clusters and the mesh to connect them via the proxy. So one feature that Consul has is mesh gateways. And so what this does is it allows connections between clusters over the public internet that's fully secured to pass all of the traffic through that mesh gateway instead of directly between the services. So your proxy would talk to the local mesh gateway in your cluster, and that mesh gateway would forward the traffic to the mesh gateway in the other cluster, which then gets forwarded to the proxy. So it adds one more hop, but it provides the ability to connect services across multiple clusters by only opening and exposing a single service to the internet or to your other clusters even. That is the mesh gateway service.
Thank you. So we had a question come in about what's the ideal connection timeout between proxies, and is that configurable? So I can throw it out to either of you.
I will be honest, I am not sure what that connection timeout is by default or if it's configurable.
I'm also not sure on that.
Okay, we'll have to follow up on that one. So another question that came in is, what's the recommended way to back up and restore Consul on Kubernetes?
So it would follow the same guidelines that we put out for backing up and restoring Consul in general. You would back it up the exact same way. Restores would be the exact same way as well. You can exec into those containers for your Consul server and run the commands that you need with Consul to perform the backup and the restore.
Excellent, thank you. And just to mention, that may also be a feature that is available on Consul Enterprise that offers automated backups as a feature. Another question, Zach, this might be for you. Can Consul control access to cloud functions or Azure functions?
So your application inside of Kubernetes can definitely access Azure functions. I don't know if Consul can actually proxy or can actually talk to Azure functions, being it's a service mesh, for your containers or your environment. Nicole, do you know the answer to that?
And I don't believe it is possible at this time.
Yeah, I think what you'd want is your application to actually call out to, or your containers or your microservices to call out to Azure Functions directly, rather than trying to use Consul for that.
Excellent, thank you. Another question that came in was asking, is it possible to configure the injection of the proxy directly on the namespace so that every app will get a proxy?
So yes and no. It's not currently possible to do it at the namespace level. I can take that feedback back to the development teams to see if that's something we can enable. But what you can do is, if you remember, we set in the Helm values file that we deployed, we turned on Consul Connect and set that to be enabled. There is an option in there that will automatically add it to every container without the annotation. So if you need it on all of your containers within a cluster, you can add that or enable that feature so that you get it on all of your deployments and pods.
Peter, I have a quick question for you. These questions that we're answering live, will we be able to go back and answer these and they'll be viewable for the people asking these questions as well? I see a few that are asking for links.
Yeah, and we'll post these on the resource page when we publish this.
Okay, perfect.
So Zachary, actually a couple questions came specifically earlier in the chat on AKS that I was wondering if you wanted to touch on. So just talking about the isolation construct for each container and whether or not they're using Linux kernels.
Sure.
Or
So
HVMs.
yeah, no problem. So AKS is actually using Docker, which is using C groups and namespaces for that isolation. And in terms of trade-off for isolation, the Kubernetes cluster is going to be running on VMs. And so you'd be dealing with the same kind of, quote unquote, noisy neighbor issues that you'd have with VMs in that similar capacity. The cool thing about Kubernetes being an orchestration layer is, as the scheduler, it will move your containers around if they go up and down. So say you need like 3 of this kind of service, it's going to make sure they're running. So say one of your nodes goes offline, it will be able to remedy that situation for you. But you will have the same kind of noisy neighbor problems because of the way it is hosted. It is still hosted on VMs on the back end.
And Nicole, a question came in that you had answered previously, but I think others on here may benefit from. Could you just talk a little bit about where Consul agents are located when you deploy them in Kubernetes?
Yeah, so inside of Kubernetes, the Consul agents run on every single node. It's deployed into the nodes as a daemon set, and these get the data pushed to them from the Consul servers so that they always have a real-time view of what the state of the service mesh looks like, so that that data is able to be accessed locally without going back to the servers as requests come in. And then any proxies running in pods inside of that or on that node would talk directly to the node and the Consul client that's running on the node.
Excellent, thank you. So we'll give it a second here to see if we have any other last minute questions coming in.
I wanted to ask a question to Nicole because I'm not sure on this. And I wanted to see if I know there used to be a Consul snapshot. Does that back up, or do you know what that actually does?
Yeah, so for the commands to do backups, you would run Consul snapshot save, I believe.
Okay.
Yeah, Consul snapshot save to perform the backup, and that'll give you the file locally that you can then store somewhere securely and to back up. And then to restore it, it's Consul snapshot restore and the file that you're wanting to restore from.
Okay, cool.
I just use kube control execs to get into your Consul server to run those.
Gotcha. Yeah, I couldn't remember. It's just something that popped up in my head there.
So we did have another question come in on this. So when it comes to security, does Consul provide both the authentication and the authorization?
So everything is authenticated using the certificates. Authorization depends on how you define authorization. We with intentions, you can control which services are able to talk to other services, but there is no fine-grained like user authentication that happens there and authorization. It's just which services are allowed to communicate with one another. So I personally think that's kind of a step short of authorization, but it does provide what could be considered network layer authorization.
Thank you. Okay, we'll see if we have any other questions coming in here. And so once again, just want to make sure everybody knows that on our upcoming event on the adoption day, we will be going through a number of different details and use cases around Consul. So we will be talking about using it in terms of integrating with things like F5 Big IP. We also will be talking about how to use it both for service mesh, but then also how you can do certain things like using ACL tokens to authenticate connections. So that may be a good session for you to listen in on if you're curious about more of the security authentication between services using Consul Connect. Okay, it does not look like we have any other questions coming in, so I think we can go ahead and wrap from here. I want to thank everybody for joining today. I especially want to thank Zach and Nicole for their time and for taking time to put together this presentation. As I mentioned, this has been recorded and we will be publishing it on our website, as well as with the questions and answers and with the slides as well. If you are looking for additional resources, you can feel free to go to hashicorp.com/resources. And like I said, information about the other events coming up are available at hashi.co/Consul Adoption Day, and then also at hashicorp.com/HCS private beta if you're looking to sign up and trial HCS for yourself. And with that, we can go ahead and let everybody go. So have a great day.